All right, our last topic is how to transmit some information from processing to Arduino using serial communication. Let's take a look at the Arduino sketch. All right, I've just got a simple variable here called count, initialize it to 0, don't need 2 semicolons. Set up the serial port to a baud rate of 9600, and now in the main loop it's just checking to see, well, if serial.available is greater than 0, so if there's a byte to read, I'm calling serial.read and letting it read that in, right? And then I'm just printing it back out. If just upload that, and then use the serial monitor here to test it, right? I can see if I type in the small letter A, hit the enter key, we get 97, type in a B, hit the enter key, we get 98, right? It's just printing it out with no new line characters, right? So it's just reading it and echoing back out what it's getting. So I'm going to shut that down. We're going to take a look at processing now. So in processing, right, we have to set up the serial library. We have to import everything. So import processing.serial.asterisk. This asterisk is a wildcard that says to import every library that starts with the string processing.serial. Right? And no matter what characters follow, import all those libraries. Then we declare that serial port object. So my port is the variable name. It's of type serial. I've got a count going here that's an int type. It's initialized to 0. In the setup function, I'm calling print array, and it's just going to list then all the serial ports. And then we open the port by calling new, right? Call the serial constructor, pass it this, literally this word, this, comma serial.list. I want to take the first serial port in the list on my machine, index 0. I want to open it at a baud rate of 9600. Now this delay is in here because with some Arduino boards over the past couple of years, I'm using a Mega. With some of the Megas, we found that if we don't delay, at this point, the serial communications don't work. So I've got the delay in here, right? You may or may not need it for your board. It just delays this from the draw function from running for a couple seconds. It leaves time for the serial communications to be established. So here in draw, now I'm calling a serial port function called write, my port.write. So processing, all right, if we pop this back up, all right, processing besides read string under class serial, it has this write function, right? So we call my port.write, we can write, then we can write bytes, we can write a byte array, we can write integers, we can write strings. So the description, it writes bytes, chars, ints, byte arrays, and strings to the serial port. You can write any of that data. It doesn't return anything. Its return type is void. Right, so here I'm just going to write out the count. I'm going to add one to count. I'm going to constrain count to be a maximum value of 255 because over here in Arduino, I'm keeping track of this as an unsigned char, and I don't want this to overflow here. All right. Now, here, if all I'm doing is writing, so if we comment out this, if we comment out this code here, and I start, yeah, right, need to comment out, and I think I've got extra curly brace there. All right, so if I comment out this, and I look at my Arduino, I can see the lights on my Arduino, the transmit receive lights are flashing on and off. They're receiving information on the processing side. I'd like to know if Arduino is getting this. Simply, I'd like to be able to read what Arduino is echoing back, right? If I was controlling hardware specifically over here, I might be able to tell on the Arduino side, but I want to read in the information this is transmitting back, which is why I had this code in here. And instead of the serial event function that I showed you in a previous example, here's another way you can read information from the serial port. So processing has an available function as well. So if my port available is greater than 0, that means there's a byte to read. Right, I'm going to call the read string function. I'm going to store that in this string called in buffer. If it successfully stores something, meaning in buffer is not equal to null, I'm just going to go ahead and trim off then any white space out of there, so any new line characters I might be sending back. And I'm just going to print out what's in buffer. So if I run this now, actually, sorry, there's my extra curly brace. So now if I run this, we're going to have this 2-second delay. And now, right, this is running very quickly. As we go through this draw loop, right, we're not doing anything with this window, but here we're writing out the count, we're incrementing the count, we're constraining it. Arduino's reading it over here. Every time it reads in a new byte, it prints it back out, it echoes it, right? And then print line here, I'm simply showing in the console window what we're getting back. A lot of times then, when I'm sending information from processing to Arduino, I have Arduino echo it back. So over here I can test to see what information Arduino is getting. Right. And so now you've got an example of how to write some information from processing, right? It's just myport.write. And then here I'm showing you an alternative method of being able to read the information in and work with it from the serial port without using the serial event function. And you'll need to use this in future labs to write some information. So you'll want to come back to this example. As a matter of fact, I recommend you get both these examples running now, right? You want to know that these work for you now. Experiment a little bit with this. Experiment with, instead of writing a count, what happens if you write a string? Can you send a string of information? Over here in Arduino, can you get Arduino to read the string? Right, Arduino has more functions than just serial.read. It's got read string. So if you go to the serial library here in Arduino, right, the reference, experiment with some of these other functions, such as read string until, read bytes, right? Experiment with some of those and see if you can handle reading in some of that different information as well, right? Otherwise, you've got a good basis now of all the things you're going to need to do in terms of serial communication for future labs.